Well, I'm Scott Ford, and on behalf of the Industry Labs team, I'd like to welcome all of you to this, the first of the Industry Day activities as part of Idea Week. It's really great to be with you in person. And for those of you online, say hello as well, but it's nice to come together again in person in these events. Industry Labs is the university's platform for collaboration with local industry. We advance the university's mission by forging innovative partnerships with local companies, uniting the region's two economic drivers, our manufacturing base and a global tier 1 research university, to advance a more productive, resilient, and skilled region. Fundamental to that effort is supporting the adoption of best practices and technologies associated with data analytics, artificial intelligence, cybersecurity, and automation. To explore these opportunities and obstacles associated with these activities, we've asked Professor Nitesh Twala to lead a panel of industry leaders who are at the forefront of this process. We are truly privileged as a university and a region to have a globally recognized leader who is dedicated to advancing the common good through his novel research in advanced technologies. The Frank M. Fryman Professor of Computer Science and Engineering at the university, Nitesh is also the founding director of the Lucy Family Institute for Data and Society and a fellow of the IEE. He has received numerous honors that reflect his contributions to teaching, research, and the community. His research is also translated into industry. Nitesh is the co-founder of Analytics, a local data science and software computing company that's transforming companies in the region. It's hard to imagine a better person and a better panel to lead the discussions and kick off today's events. So with that, thank you, Nitesh.
Thank you, Scott. Good morning. Thank you, Scott, for the kind introduction. Thank you. So good morning. Welcome to an exciting panel that we have here. We will be talking about data-driven decision-making for business, and it's truly a special privilege to have three experts from industries who have been either translating the impact of data to their respective businesses or developing algorithms or technologies to help businesses translate the impact. So I'll quickly provide an introduction of the panelists that we have here today with us, and then we'll invite them to share some of their thoughts, and we'll engage in a Q&A. And I am told that there is something that's going to happen on the screen with some clicker magic, and that will appear on my screen. That's all I know. But we'll see how it goes from there. So first we have Norma Grubb. We are very grateful for her to drive up from Indianapolis and to this beautiful sunny weather of South Bend after Easter, and where she is the Analytics and AI Director for the Chief Digital Organizations at Cummins. And she partners with business and function leaders to truly deliver insights and develop predictive analytics approaches and how do we translate them into business needs. And some of her work has led to significant savings through use of analytics. For example, $40 million of savings through the work that she and her team have done at Cummins organization. She's an avid speaker. She's been invited to give talks at different organizations, different events. So we're really looking forward to have her discuss and her vision, her ideas, and even what Cummins is doing with analytics. She is an active member of the community in Indianapolis as well, where she serves as a board member of Just Friends, an adult daycare that supports underserved elders in the region. And as part of the finances committee at Cummins, she also contributes to the sustainability of the organization, Just Friends, to fundraising activities, budget management, and strategic planning. She holds a Doctor of Professional Studies at Syracuse, a Master of Science from University of Texas in Information Studies from University of Texas, and she also has a certificate program in design and manufacturing from MIT in 2021. And she is used to and she mentioned earlier today that because of Syracuse and then years in Canada, this weather is piece of cake. This is springtime. So welcome to spring.
I love the spring here. Snow in the spring is delightful. The best
then
snow.
we have David Cieslak. So David Cieslak is the chief data scientist of the company that Scott had mentioned, Analytics. And he is, as a leader of chief data science at Analytics, his team is truly responsive. He also heads a lab called the Innovations Lab, his team is truly responsible for imagining what would be the algorithmic innovations, machine learning, data science innovations that can be translated into business impact. So they imagine what could be embedded as answers into the data itself, such that when folks are using the data, they are not just asking and figuring out what the answer should be, they get the answers delivered to them. And the term that the team uses is called smart features, because they are so smart, they have the answers before you ask. And Dave is a triple domer or a quarter domer. He got his bachelor's, master's, and PhD from Notre Dame, and then he stayed on as a research faculty as well. So, he and his wife and his children live in South Bend, Indiana. I am told he had a wonderful PhD advisor when he was at Notre Dame, Dave. He may share that with you, who his PhD advisor was. So again, Dave, thank you. And I'm looking, and Dave will share with us some of the experiences that he's been with Analytics from day one as a first data scientist of the company. So hopefully he can share some of his experiences in his growth to building, growing, developing technologies, and building a team, and also working with some of the major corporations in ensuring how the data-driven decision-making is translating to their impact. Last but not the least, it's a pleasure to also welcome Matt Harrison, who's the Director of Design and Business Intelligence at Chase Manufacturing. Chase is located in Napanee, Indiana, where it specializes in the highest quality custom design interior wood products for the RV and manufactured housing industry. And clearly, as you can imagine, a lot of questions that press on, in the brief conversation that I was having with Matt earlier, the pressing questions are how data analytics, predictive analytics can help inform supply chain pressures today, which every organization is facing, pricing that may come in, the variability in pricing, etc. So that's something that he's thinking about every day, and not just about wood manufacturing. And as part of his expertise, he's responsible for taking innovative ideas and translating them into practical business solutions. With Chase, customers on the bottom line in the front of his mind, Matt has produced unique applications and integrated a company's software and data streams into comprehensive decision-making tools. In addition, he works with Chase's internal teams as a subject matter expert in design and engineering management, as well as a full stack developer and a data scientist. Matt, what is left? We'll know from him today as to what exactly additional things we need to add on his full stack list already. So thank you again. So clearly there'll be a good dialogue with Matt as well. He could be having multiple dialogues with himself, manufacturing versus data science, but we'll try to get those dialogues with all of us here today. And even Matt's serves as a technical advisor for, as part of the community service, Vibrant Neighborhood Pilot Initiative in Elkhart County, Indiana, where he's working with a team to develop tools that help community members plan and organize events and communicate more effectively. So clearly we have a stellar panel that will lead to some amazing discussions and dialogues today. So please join me in welcoming them. And with that, I'd invite Norma to.
Thank you so much. Very generous remarks. I can't do any magic with the screen, so that is left. Sorry about that. No magic. So I want to talk, focus on one of the most important elements in artificial intelligence that is usually overlooked, and it's actually the title of this panel, which is data and data flows. There is much emphasis always placed when we do artificial intelligence on statistical models and data science. So people often ask me, do we have to use a deep learning model, or do we have to use a neural network, or do we have to use a decision tree? And actually, they can ask you what are the best model for vision inspection, which is one of the most popular type of artificial intelligence tools being used right now. Or how we process image data to make intelligence out of it. But the truth is, nothing replaces good quality data. What we need to develop any artificial intelligence solution is good quality data. Otherwise, any data science model won't be as effective. So it should be a continuous flow of high quality data to any model. And what do we mean by high quality data? There are 7 aspects of data quality that should be considered in order to consider some data output good quality. And I'm going to mention the 7 now, the 7 ones now. First one is accuracy. The data needs to represent what it intends to. And this seems obvious, but it's in a situation in which we have, for example, legacy systems with data that was gathered for administrative reasons, and we want to use it for artificial intelligence, which is a different reason. That data that we are gathering may not represent exactly what we are intending to look for. So an example, do we have data about product inventory, which is one of the problems in supply chain right now? We need to make sure that the information stored in the data set correspond exactly to, for example, the barcodes scanned from specific products that we want to track and not some other products. Again, this seems obvious, but when you have manufacturing plants across the globe in different languages with different technologies, may not be as obvious to try to aggregate all that data. So there are nuances in the products, different versions of the products, product being superseded. Everything needs to be reflected in that data in order to be accurate. And this type of reflection of reality is what we mean by how accurate data is. The second element is completeness. And this is usually when we talk about data quality, we think about how complete the data is. But it's just one element of data quality, completeness. It refers to the fact that all data should be present when you call the data. Lack of completeness typically shows in the presence of null values. When we look at a table, we see absent values or null values. Particularly in real-time data, which is the focus of this panel, this is a problem. Null values happen for many reasons, including interruptions in the data flow due to sensors being disconnected or problems with bandwidth, or interference in the connectivity that causes those null values. These affect data completeness, and in consequence, our ability to fully represent reality using this data when we run a model. The third element is consistency or integrity. And this refers to the fact that data records and their attributes should be consistent across time and systems. And this is a big challenge as well. We may have situations in which we have several manufacturing plants using different systems. The systems represent the data in a different way. They have different definitions for data points or metadata tags. And all this interferes with the quality of the algorithms that we develop, because the output has assumptions that actually the data don't support. Different software applications in a variety of devices and locations should gather, process, and represent data in the same way. That's how we make data consistent. In a smart factory, as I mentioned, this is particularly challenging because smart factory processes, or like automation, they are heavily based on having a continuous stream of data that has good quality and that represent exactly what is meant to represent and is uniform across different systems. Reasonability. Reasonability refers to when data meet the assumptions and expectations of their domain. For example, one typical indicator that we have in manufacturing is OEE, overall equipment effectiveness. And this indicator tracks productivity in the floor plants. So say, okay, do we have all our equipment working and running right now? Or do we have downtime in the equipment that will prevent from the manufacturing shop to deliver the throughput target that they have? So there's an indicator called availability of data equipment that is part of the OEE indicator and refers to both planned and unplanned downtime. So planned downtime is when we have maintenance in our equipment, so we shut down the machine to conduct maintenance, and that's planned because we know next Tuesday, 2 p.m., we're going to shut down the machine. Unplanned is when something happened and there is downtime. We need to track those in order to have a predictive way of producing our manufacturing throughput. So for this indicator, in order to have reasonability, the data should be segregated in such a way that both type of events, planned and unplanned downtime, are clearly distinguished and their assumptions represented. So, for example, if downtime is due to some operator leaving the workplace because there was an accident or something happened, is that represented in the data? Or this was a planned downtime. Timeliness. This is another aspect that usually we understand when we talk about the problems with quality in our data. We talk about not having enough data on time. So this is a pretty well-known factor. Up-to-date data should be available when needed, and there's missed opportunities when we will have enough data to predict or to develop AI algorithms. And these missed opportunities usually translate into profit loss or losing savings as well. Uniqueness, another factor. Each data point should be unique, so we shouldn't have any duplicates, and big amount of time we spend just eliminating duplicated. Again, it seems minor thing, but it's very important. And the validity of the data, which is that data conforms to the domain it belongs to. So, and this sounds fancy, but it's actually, for example, if we have a column that has a date, making sure that the date format is date and not numeric or text. This is simple again, but all these details, you know what the devil is in the details. When we try to develop a data science model, our output will be flawed just because data cannot be captured properly. So you can imagine that in global companies such as Cummins, complying with all these factors of data quality is not a minor task. When you have several manufacturing plants across the world, all with their own system deployed, using different methods for historical reasons, this task can be daunting. Now, I'm going to talk about two more aspects in the few minutes that I have that I think they are very relevant, and in our experience at Cummins has been very important about considering data as the most important asset in any AI solutions. Data science predictions are as good as the data that fits them. So this is the canonical garbage in, garbage out that we have heard. I'm in a university, I don't have to tell you this. You guys are all scholars. AI is a statistical discipline. I will challenge everybody. AI is a whole bunch of statistics running super high speed. That's all what it is. There is no real magic. It's really, we finally, as Pythagoras wanted to do centuries ago, we finally managed to represent the world with numbers, and those numbers make us predict what's going to happen in the world and make it automatic, and that was AI is. At the heart of algorithms are data science models, which are mathematical representations of the world. So again, I will dare to say that artificial intelligence has centuries on the making, since linear regression and Bayes probabilities models were created in the 18th century. The power of computers now bring more scalable and fast statistical processing. So if you can imagine hundreds of statisticians processing large amount of data in sequence, then you have a picture of a neural network. And all that happens in your computer because of the power of computational solutions right now. So the old statistical saying, garbage in, garbage out, is still fashionable these days. And the data quality factor mentioned above are critical, as critical as they were for Thomas Bayes when he created his conditional probability theorem in the 18th century, which is at the center of many of the things that you use in your phone when they predict text, when they perform artificial intelligence tasks. I have two more elements that I want to mention. The other element is that data collection, storage, and preparation is expensive. and we can bypass it. We need to perform this task in good shape in order to develop good artificial intelligence models. We all know that data is an asset, but a few companies are willing to pay for what that asset is worth, not only in terms of storage cost. Storage cost is one thing, but also investment in quality control. We need to apply those 7 attributes that I mentioned before. And for that, we need people and systems performing data cleaning and data preparation processes. This requires specialized labor by data engineers who should have enough understanding of both what the data represent and also the best practices in the industry to create cleansing and formatting rules. All these activities are an investment that the company has to make. And there are plenty of examples around us about how profitable this investment can be. One of the examples is telematic service providers. These are companies that collect, process, and make available big data streams from sensors and other real-time monitoring systems. So these companies gather information from the sensors and make it available for us. In fact, those telematic companies make a living, and a very good living, out of processing, cleaning, and making readily available real-time data flows. This is the best evidence that data is a competitive asset that can be treated and sold as a commodity. Manufacturing companies need to understand, value, and invest in that asset, not only for their own competitive advantage, but also to keep up with the state of the art in their own industry. Anything revolving a particular product and the product's consumer should be represented by data. And not only data as a byproduct of transactional processes, as I mentioned before. That's how historically we gather data. We put an application, the application has some software, we start to gather data, and then we want to use the data for something else. But intentionally, we should be designing data flows for artificial intelligence as mathematical representations of products and reality. And this is the magic behind prediction and automation. The last element that I want to mention is we shouldn't confuse, when we talk about data and artificial intelligence, we shouldn't confuse a proof of concept with a final digital product. Proof of concept is when you, I know, we all fell in that. When somebody in their own computer, in their own laptop, in their own corporate laptop, they are very curious, they get in the internet, they get some code and they get some data set, an Excel file from some system, and they develop a model and boom, they have an AI algorithm working. But the algorithm is just what we call a proof of concept. This person is proving that a concept is possible. From there to get into a product is a long and expensive way to go. So having good data as an algorithm is not enough. Analytics and AI products need to be packaged and delivered to end customers according to their accessing preferences, the technical infrastructure they have, their analytical needs, and they should be delivered in a timely fashion. We should not undermine the end-to-end process. When we create from AI solution creation and deployment, because it's complex, expensive, and it's time-consuming, and has many, many other fields that are not data engineering or data science. Any AI solution, such as robotics in a smart factory, should be treated as product development to properly represent these end-to-end processes. Some steps that are not data science or data engineer are, for example, cybersecurity compliance with cybersecurity policies, architecture design, how all the elements in the end-to-end workflow fit each other. This architecture should be scalable and provide optimal performance. And software design. Software is the digital package in which we access this intelligence, such as a dashboard. The most common is a dashboard. When people say, I want a dashboard, there is a user interface that is not the data science model, which allows us to understand the data science model output. Or API calls, mobile applications, any app we have in our cell phones is a piece of software that has intelligence behind. And that software needs to be developed, and it's not the field of data scientists or data engineers to do that. Perhaps one of the most clear examples of all these elements playing together is automation. In automation, there is an artificial intelligence algorithm making decisions automatically about how and when to process information or perform a task. But the entire end-to-end involves proper connectivity to data, human interface such as a physical robot or a digital screen with buttons in a computer that people can press, and everything behind the scenes in terms of cybersecurity and architecture are components that are part of this product that is way beyond what data science field is. So finally, in my view, the use of accurate and instantaneous data is dependent on all these elements above. And as a practitioner, I wanted to bring my view to this audience. These are the challenges and opportunities we find at Cummins right now. Every day when defining the next generation AI, we want to attach to our products. Thank you.
Thank you, Norma. Dave, if I may, we'll save the questions for the end. Dave, if you may want to chime in with your
Sure, yeah.
thoughts, please.
Norma, thanks for your wonderful thoughts. One comment that was baked in there that I really, kind of harkens back to an old joke that the most common deployment platform for artificial intelligence is actually PowerPoint. A lot of times we're not seeing the actualization of technology being built into an operational sense. And it's kind of interesting to see that journey that we've really been on. To Natesh's point, I've been lucky to be on a kind of a data science revolutionary. That kind of journey began way back in 2008 formally, when a couple guys at LinkedIn really kind of, baked that into an idea and into a practice of business. So back in the day, you might have seen people looking in dark rooms, analyzing information, running things through risk models or predictive models. They're really kind of to be maybe a little bit heard and definitely not seen. But what's exciting is to even look in things like pop culture these days, to see things like CBS television shows or The Blacklist or Avengers movies, where people are always plugging data into models or presenting information and tracking things down in really interesting ways. And it's been an incredible journey to see how over that short 15-year period or so, things have really progressed. But to tie back to LinkedIn, one of the progenitors of the idea of this data science field is this guy named DJ Patil, who actually worked as the chief data scientist of the United States during the Obama administration. And I was really lucky to get a chance to meet him at the South Bend Code for America event. I want to say it was 2016, could be wrong, but ballpark. And we had a good conversation about data science. And he was really excited at the time about hearing about the firm that we're starting up at that time called Analytics, because he shared with us an anecdote that anytime he wanted to work with municipalities or civic groups together, it was a $100,000 price tag just to get the police department and the fire department's data to work together. Immense costs on all fronts. And I think Norma really covered a lot of those elements in there. Huge price tags, just lack of access to information. There are a lot of drivers to that overall. And that was really kind of some of the insights that drove, I think, Natesh in particular to found groups like Analytics, the Lucy Institute, or the industry labs, just groups that are really focused on bringing that access. Because what we've seen in a lot of our experiences, there's a lot of great, the pop culture results that we're seeing everywhere taking over, but a lot of those are kind of at these mega firms. So kind of your Microsofts, your Facebooks, your Googles of the world. And they kind of lock those things away. They kind of look at the Midwest as a little bit of flyover country. And there's a real need to bring that information, not just from the West Coast or the East Coast. Like technology and data problems happen there, but they're happening everywhere. And the Fortune 500 isn't the only groups that deserve to have these things solved. And it's been really exciting to work with these partnerships and angles to figure out how can we bring data science as a practice or machine learning as a practice to those groups. And so we've kind of observed along that way is some of the major barriers for entry that we see for any kind of small or mid-market groups is, first of all, people that like data scientists or analytics roles, they tend to go for what I call vertical expertise. They don't necessarily want to be the data scientist at a small bank. They don't necessarily want to be the data scientist at a manufacturing group. Maybe they do, but you never know. but in a lot of cases, you see, I'd rather, whenever we interview someone, they'll say stuff like, hey, I want to go to a place where I'm going to get mentorship about being a data engineer, a data scientist, or whatever, and stuff like that. And it's really difficult to attract that sort of talent to a specific company because they're not always assured they're going to get that sort of coaching. And so what's been really great about having groups like the Lucy Institute in analytics and industry lab is to kind of start to get kind of those kind of clumps of really young, talented, bright individuals that are all really willing to work together and learn from one another. The other thing as well is for, especially for smaller groups, is that the technological landscape right now is super confusing. I can think of my 15 to 20 year journey in the data science space and thinking how many little things have gone, or you know, how many decisions have I made along the way that have been about impacting technology and learning technology expertise. So you'll have your classic, like, should I have learned R or Python? You know, maybe I would have faced that one in 2007. And you know, what was to me a personal choice to figure out, man, Python's the coolest language ever. That is actually a real huge enterprise choice that a lot of groups, particularly in manufacturing, might not be willing to bite off or understand some of the downstream ramifications if they go to that lesser angle R. What might that inhibit them to be able to do downstream a little bit? So there's a lot of technological choice and navigation that has to happen along the way. And we've been lucky to not only bring in data scientists and data engineers, but people that are true cloud experts. They know a lot about computing hardware, software engineers that are bringing great things about containers and microservices as a philosophy, as things that, you know, as me as a data scientist, I don't care about those things, but I'm glad to have people that I can work with at a company like mine that know a ton about all those things. Because when you talk about having an AI where, for example, a great example might be something that can look at units coming off a manufacturing line rather than having a hand inspection, right? Something that can look at photographs of a device coming off a line and understanding if there's a problem or not. It's not just, it lived in my PowerPoint on my computer, right? That has to live either in some sort of a pub sub message system, or that has to live in a web service along the way. And those are things that I had no idea about. I kind of thought I knew about, but you know, when you talk to real experts and you can build these firms that know things not just about data science, but can really tap into a lot of the adjacent technology space, you get really powerful results. What we're seeing in calling an AI isn't really just a matter of the next extension of just ML technology. It's kind of the blending together of software engineering, hardware, cloud tech, logging, and of course the ML is baked in there as well. So really powerful, and that's a lot of what we see lacking necessarily in some of the kind of the smaller groups is typically they're interested, they have problems, but the economies don't scale for them, right? Usually where you know, people that can solve a problem in their space, if they're a small mid-market group and it's $1 million for them, that problem's $100 million for a really large group. And so the economics are going to drive the tech talent. They're going to drive all the big firms to kind of work to solve that for them. So what we really see is the need to be able to kind of leverage our groups and scales within kind of local partnerships and helping solving problems for those groups. So I think when you look at what we've been able to pattern with kind of the analytics and data science firms, I'm really hopeful that over time we'll see kind of a dispersion into different localities. Because I think that's going to be a really powerful way for groups to kind of partner up with other mid-market groups along the way. So I'll just say very excited for what data science has done. I think over the last 15 to 20 years, we've seen a ton of things, not only in the growth of the technologies, right? Like I remember going into an AI class in 2004 and someone telling me that Go would never be a solved problem. And now we've got AlphaGo out there, and it's you know, it's effectively considered to be a solved problem. And seeing kind of some of the things that have happened along the way, and it's really an amazing journey to seeing what we're able to do kind of at those big scales, but also seeing kind of how Varian from Google says stuff like, if you see what the big groups are doing in 5 years, everyone's going to be doing that thing. And it's really cool to see what we're able to kind of port from some of those larger groups to all the firms throughout the country. So very excited to continue our work in the analytics space to making a real impact on our local community.
Thank you, Dave. Matt, please.
Yeah, so I think it's really important to give you guys an idea of what Chase Manufacturing does first, to kind of let you know where we came from. So I actually started at Chase Manufacturing 6 years ago, and the only data that we actually had available to us is that the sales orders that were entered and the invoices that were sent to the customer. End to end inside of that business, there was literally no data available. So part of my primary role actually there, what I was hired for, really was just actually engineering. So I have a pretty diverse design and engineering experience, interiors, kitchens, wine cellars, those things. And I kind of worked a lot closely with our customers to develop these interiors of these high-end motorhomes and the like. But going into Chase and seeing that there was no real infrastructure there for engineering either, it was really hard for me to provide to our customers, for example, a list of our capabilities, our tooling that we had available. So I immediately started tasking our engineers, grew my department, and set up agile project management techniques in order for me to really facilitate quickly and at scale the collection of our engineering capabilities or manufacturing capabilities. When in doing that, I kind of really started to realize the issues that we had in our cultural space. We had a lot of decisions being made by the gut, uninformed decisions, or decisions that were made through anecdotal evidence or through, just memory, which I don't know if any of you can agree with this, but memory is often at fault. I mean, we remember one thing one way, but it's not necessarily, all the context isn't there to rely on. After collecting a lot of the engineering information that we had, I was able to actually start to challenge our manufacturing groups and say, how many profiles do you think you run through this molder in a day? And then they'd go, oh, 50. Well, it's actually 130. And they'd be like, oh, well, yeah, if I sat them down and tried to have them work through, counting out everything, they still would fall short of the actuality. Part of my evolution in the company began, how can I get better insights? I began to get tasked by our customers even asking, where is this order on our line with only invoices or sales orders and invoices in there? How do you even begin to draw that out? Well, you end up having a conversation with somebody and they think you're talking about this order, but in reality you're talking about that order. So clearly transactional data inside of a manufacturing system was absolutely critical. I had a lot of experience with developing engineering systems for teams, and I've also written some software applications. So I figured, since we don't have the access to capital, I'll write some myself. So I wrote a C# web application in ASP.NET that began to house our bill of materials and our routings. And then I realized, okay, so now we have a good foundation of what we should be making. What about transactional data? So I made a Python application that began to collect transactional data through barcode scanning throughout the manufacturing plant. Really, the principles that were described here with respect to the quality of data really are important. Those systems that I built them on really good foundations, SQL Server, PostgreSQL. So I knew that I had the data types all managed in the right way. When I started working with Python, that's when I got into the machine learning space, and I'm like, oh my goodness, this can save me some time. One of the things I didn't tell you is that our customers, they change model years every year. Okay, so as a company that services several manufacturers, we go through 12,000 new products every year, and those are just the sellable ones. When you break it down into WIP, you've got hundreds of thousands of products. And so how do we manage that in our engineering department? Well, we've really leveraged, for example, a TF-IDF is a text vectorization algorithm that allows us to, with a support vector machine, classify what product routing that this product goes to just based off of its description. Using other convolutional neural networks, I can classify that this engineering document actually belongs to this product group. So I can help assist our engineering team with making better informed decisions to handle that inflow of products. 12,000 products in a year, 365 days a year. That's a lot of products every day that we're working through our team. But we developed these tools internally to be able to assist us. We have the transactional data now that we can start to leverage it for determining what our capacities are, throughputs, and also even predicting what product categories have a higher probability of failure, or having warranty issues. So what we've been fortunate, though, that we've actually worked with Enfocus and the industry labs, and they've helped us write a grant, and we were accepted for that, which is great, from IEDC, and that's also helped us bring in the technology resources that we needed, like the hardware, the infrastructure that we need to continue to scale. So, I think that really does a pretty decent job of summarizing our journey at Chase Manufacturing. And fortunately, we don't have just sales orders and invoices. And when our customers call, we can actually go to the spot where that material was last at, and we can find it and then give them a pretty decent feedback where it is. So that's
Thank you. So, there were 3 quotes that I think I'm going to print T-shirts with. That these are wonderful speakers said. I'm going to use machine learning, save me some time, right? Or saves me time. There's not even a question about it, right? We'll just say saves time. And then Norma, data conforms to the domain, right? And Dave, data science as a practice. And I think why these are profound is that for data science to be a practice, one must know the domain because the data is conforming to the domain. And then once one is using machine learning, what is it helping a business leader do to arrive at a more accurate, consistent decision, hopefully saving time and helping either the bottom line or the top line, whichever way that may be used at. So to get to the practice, I think the appreciation of the domain, that vertical integration with the technology, and then as well as a proof of concept is not a product or final digital product. That's extremely true because we could use a model to demonstrate the utility. Proof of concept may be the journey step number 1, where you marry the domain with a machine learning technology, but then how do you now make it happen such that every day you wake up, things are being delivered and the answers are being given as you expected, to adhering to the 9-8 bullet points that Norma so well articulated, from accuracy, completeness, consistency, etc. So I think this is wonderful, and the way you all were taking off each other, I felt like this was like a rehearsed session, but they haven't met before. It's the first time. So clearly these are thought leaders. When thought leaders are talking, they sort of identify a big set of challenges. So I guess let me ask the audience this, and we'll invite the audience to ask questions as well in the interest of time. How many of us in the audience are either from a manufacturing company or the mid-market and are thinking about embracing a data journey in their respective companies? Show of hands. Right. Is that, and so were there, and I guess when you think about that, and if you're asking questions, so think about the points that he's raised. So at Cummins, you said, you've developed a complete, you have the dashboard and everything else. And Matt, at Chase, you've said that, you were the change maker, right? Where you said, I need to bring in invoice data and I need to bring in the pricing data, and then I need transactional data. You fell in love with Python like Dave did. And so you both of you do Python now together on that. So how should a mid-market or a manufacturing company thinking about this, and then daunted by the challenges of data quality and real-time data consistency, what should be step number 1? And Dave, you have worked with these companies as well. So I guess any one of you can answer, what should be the step number 1 for these organizations?
So I would say there's, two major steps you want to take right away. And from my view, when you see these things working out well, there's always kind of maybe a design thinking type exercise where we're exploring the space of issues that you actually have. Because as you said, data conforms to the domain, and the domain defines the space of problems that it can actually then be solved. So sometimes the data you have available constrains you to potential solutions, which is an immense thing to make sure you consider up front, so that you don't waste a lot of time downstream trying to solve a problem that you can't with the data that you can have. The other thing I would, I'm biased, I would say look for local partners. Typically, great success story over here of someone who works in manufacturing on both my left and right, but it's not often that you're going to have maybe quite as much analytical talent available to you as well. So if there's certainly some sort of ability to tap into local resources and partnerships, it's probably a really strong angle, since there's people that have been through the journey before, they know the steps, and they're going to be able to kind of accelerate your learnings and development in the space, would be my feeling.
I have something to say on that. I think that your basis of how you collect your data is really important. So the systems that you choose, like an ERP system, is really a fundamentally important part of your business. You know, that there are several applications out there, and if I were ever going to do what I did again, I would choose a software stack that would be like one that's a community driven. I think there's a couple open core softwares that come to mind, but I think that really choosing an application that can scale with your business and allows you to kind of get you those data points that you need to act on is really important.
I agree with what my colleague said, and I will add, start small with a good business case. Business case, I mean, you know, with the investment that you have in this solution, what the return will be. I'm sure, you know, if you work in a company, if you're aspiring to work in a company, there are many stories of failure with artificial intelligence. Every single company had a big disappointment investing millions of dollars or hundreds of dollars in something that didn't work. So the first challenge is to gain trust with your business partners. And for that, I will say start with a use case that is manageable, that you have all the data and you can show pretty quickly good, reliable results. And then that will gain the trust that you need to keep building momentum and getting bigger use cases that will transform the company.
Thank you. There are questions as well on this, and as well as question in over here. I think there a mic which is that we should use for questions here, Susan, or everyone should type into the screen and I repeat the question. And if somebody in the audience has a question, they have to type in. If you can say your questions, I'll repeat it.
Okay, I'll speak up. So I was intrigued. Your mention of MIT, it sparked a question, another good answer, and you just responded to the basic and how you start. I've got a question more at the advanced level. Have you been looking at any of the things on advanced innovation or chaos and complexity theory in terms of thinking about the next phases of data science?
The question was that we've talked about beginning. What about the advances and complexity in with the innovation theory, etc.? So
yes, thank you for the question. Well, the new advancement in artificial intelligence involving chaos and complexity, they are experimental. And, you know, when you work in a company, I don't work in the R&D, in research and development. So my scope of work is more about making things happen for real, for good. And for that, we need to use very well-proven algorithms already. So I'm aware of these trends, but we don't use them actively in my line of work, in my particular line of work. But they are very promising.
Thank you
for the question.
I'll take a question from this. This actually works. This is really cool. Questions are popping up on my screen. I'm like, this is magical.
Yeah.
So Jose Lopez is asking, and I sound like a talk show. Jose Lopez is asking today. This is your NPR channel speaking. What are some best practices to maintain or even fix data sets with poor uniqueness?
Well, the absolute best practice, I will say, is to apply the 7 principles that I mentioned. That's the best beginning. You need to have reliable systems because some of the data loss has to do with lack of connectivity. So if you have a very robust infrastructure that will prevent data loss, then you don't need to handle inputting data or all these techniques in order to try to fix data losses. So I will say applying the 7 principles of data quality and having a very good data infrastructure. Thank you. Good questions.
Yeah. Anyone else wants to add to that anything, or Dave?
I mean, there's dozens of Python libraries, like Pandas is really good for getting data and transforming it so that you can kind of work to weed out those discrepancies that you might have in data types. And then there are other ways to handle null values other than just dropping out the data. You can use machine learning to be able to fill in null values if it's appropriate. Of course, you want to make sure that it's producing the right results that you want and you're expecting. But yeah, there's other ways to handle it, like using the mean of a data set. But it really does depend on the data that you're working with in the domain.
Yeah, I think that's pretty fair. I mean, you can use machine learning and all that the statistical methods you want to try to treat the data once you've received it, but prevention or capture is clearly the preferred strategy to try to solve for that problem.
Thank you. Don Kinelkius. Hey, Don, how are you? Long time. Can you give some sense of Chase manufacturing scale, employees, plants, revenue, to understand why you started this work on your own?
Yeah, sure. So we now have about 160 employees. We're across 3 different locations in Napanee, Bremen, and Elkhart. There's a lot of reasons I think that I chose to kind of get more involved with it, and a lot of them come down to, I think I just have a lot of compassion to help, and seeing that people are struggling with getting accurate information to customers and getting accurate information internally was something that was challenging, I think, that I needed to solve. And of course, being a designer, I wanted to make sure that I could give the customers the highest and realist expectation of what our capabilities are. And so it kind of drove a lot of that journey that I went through.
I think that's a fantastic way to frame it as well. When you're in the analytics space, you're really a servant leader to other business units or business functions. Typically, you're providing insights or you're providing capability to enable better decision making. So I think when you frame it like a servant leadership, that's a fantastic way to look at it.
Yeah.
Thank you. I'll take one more question because I think we have 3 more minutes, if I'm not mistaken. Susan will tell me. Thoughts on how businesses can get data, keep it, and use it in an ethical manner. So basically, the question is about ethical use of data and how the businesses think about it today.
Well, I would say the first thought is to comply with countries' policies. Different countries have different policies. Now, the ethical aspects of data, they mostly apply when we have personal data involved. So for example, in our case, we have several, we apply policies in data that we extract from the fleet trips. So we are a company that manufactures engines. Our engines get into a truck. The truck is part of a fleet, and the fleet has a route, and the route has a driver. So with some intelligence, you can get to what the driver is doing every day. And you have in a database the name of the driver. So the best way to make sure we respect the privacy of individual is to totally detach the information, the personal information, from the actual data of the activity of the engine, and aggregate it as well. Aggregate, and so detach from personal information and aggregate the data. There is also, I know there is a lot of controversy about AI and ethical applications of AI. I would say AI is a tool as much as a weapon as anything that human beings produce, you know. Again, garbage in, garbage out. If an algorithm has biases, it's because the data we train it with, it was biased data that we selected with their own biases. So I understand the concern about the ethical uses. At the same time, I believe that this is just a tool like any other tool that can be used, like dynamite. You know, we know the century was used for fireworks, and then somebody created weapons. So AI may be the next dynamite, but it all depends who creates the tool.
To add on that, I would say from an AI perspective, a lack of testing or sufficient testing is oftentimes kind of, I'd say, almost unethical in a lot of ways. There's a famous software repository company that ran a lot of public code through an AI algorithm. Nominally, it was to do something good. They wanted to help developers write code faster. But what they were finding is when people wrote small bits of code, they were getting private code from other people that just got spat out whole cloth. So they were effectively disclosing, intellectual property because they hadn't properly tested their AI. So as you're getting into these really advanced, crazy states, AI is really poorly understood in a lot of cases what it's doing. And so it's, very ethical to make sure you're testing your systems to the extreme to make sure that things like that aren't a situation that can happen.
Very good point.
Mm-hmm.
I mean, I fortunately don't have to deal with consumer data. Privacy isn't really too much of a concern right now for what we're doing at Chase. We do have aspirations in the future to put a lot of IP cameras out in the plant, and so the question might become, how do we consider privacy of our employees as they're doing their work? I think that's a question I think that we're going to have to see in the future how that folds.
Thank you. Oliver Bilsland is asking, how can you tell invalid data apart from valid data? And do you use any part of invalid data?
It's a very good question. I will say, for example, when you use some of the machine learning techniques that my colleagues mentioned, those work with the small input in data. When you have a few null values, you can recreate. And the way to test, I will say the way to test is to take samples. So what I will do is I will take samples from the overall population and compare using techniques such as median and looking for a distribution that can be represented. At the beginning, you need to trust a lot the subject matter experts. So when we are in a transition from, as Matt mentioned, people mentioning, we need to ask somebody who knows about a particular activity in your company. Otherwise, there is no data available. You just need to trust somebody's judgment because they have seniority in the company. When you go from that state of situation to a system that has enough data in order to represent the problem you're looking for, you need a transition in which you need to, in our case, we continuously ask as our subject matter experts if the samples that they see make sense in a very analogic way, if they make sense. The future state that we have in some of the solutions is to have a data flow that is robust enough that we know that is continuously delivering good quality data. But I will say from, the best guess that an expert has, because they spend 20 years in the company doing that work without any system, so they know how it goes. From there to an expert system is a transition. And at the beginning, you need to judge human judgment. And machine learning also relies on human judgment in many ways in order to give the final validation that, yes, this is accurate.
I would say that to address the original question, data science practice is effectively a QA on data production in a lot of cases. So you're really couching what you're seeing coming out of a data building system and saying, to tap in there with the domain expertise to understand, do these values look right or wrong? Clearly, one of the most important functions in my view of data science practice is to actually recommend to the business or the IT departments how to enhance their processes to actually improve their data asset itself. So there are a lot of things that you can do within your analytical process saying this data looks suspicious, or couch it with confidence bounds or estimates or things along those lines certainly are useful. But your primary responsibility in my mind as a data science professional is to actually be making those recommendations back upstream to your enterprise to getting that data fixed, because as we all know, data is your chief asset within whatever company you might be working with.
I mean, this is real-time data collection. So if you're seeing a lot of issues in the data that you're receiving, you really got to go to the source of the collection. Like, how is this being collected? What issues are occurring? Occasionally, what come to my mind was anomaly detection using unsupervised learning. Like, maybe that data point is actually indicating something else. And again, it comes down to probably a subject matter expert being able to tell you that this anomaly actually is something that we should be more aware of. So, but it does matter the quality of the data that's coming in, and that's probably the first place to look.
Thank you all. I know we are at 12. I think so one of the key takeaways I would say, even from the last question, was that data science is a team sport, right? You need folks from different expertise to make the team. And we often hear data is an asset, but what I would add to that is it is an asset with an option value. The option value comes from what we do with it. Right? Until then, and that's the valid value. Well, let's thank our amazing, wonderful panelists. Thank you. And I guess enjoy your lunch, and thank you for coming in today. Appreciate it.